Welcome to this next introductory video here. Today we're going to very briefly introduce another class of functions that is important in our applications. That is the class of trigonometric functions, or more precisely, the sine and the cosine function. So this is again part of the introduction. And this is called trigonometric functions. I'll give you one possible definition of the trigonometric functions here. This is by no means the only possible definition, but that's probably the one that you're used to from school. And just discuss some very important properties very briefly. So what you usually do to define the trigonometric functions is you use the unit circle. Exactly what we're doing here. Draw that quickly for you. Okay, so I say 1. Here's 1. Here's -1. And here's -1. We can draw a circle around here that looks like this. Not too bad. And on that circle, we can mark a more or less arbitrary angle. Do this by saying mark this angle here. So that is the angle. Let's denote that by gamma. Then this gives us a triangle, and that's where the name trigonometric function comes from, of course. And that triangle has, apart from this gray side here, it has this side and this side. Draw that, this side here first. And then another one in green. And the length of these sides here, those define the trigonometric function values of sine and cosine for gamma, angle gamma. So the green part is called the cosine of gamma, and the orange part is called the sine of gamma. And that's how you can define the trigonometric functions. Imagine if you rotate that angle gamma here around the unit circle, then the length of those sides changes, and it changes between 1 and -1 side. So that's the codomain for those functions. So basically, both sine and cosine are functions that are defined on the real line, and their function values are between -1 and +1, so that can be used as the codomain. Of course, with every whole rotation around that circle, the function values repeat. So that means both functions have a periodicity. They take on the same function values. You rotate a whole circle and then some. And that period is 2 pi. One rotation of the circle is an angle of 2 pi. So that means sine and cosine are 2 pi periodic functions. So if you add some multiple of 2 pi or subtract some multiple of 2 pi from the argument, that doesn't change the value. Okay, so sine and cos are 2 pi periodic. And that means sine of gamma plus 2 pi k is the same as sine of gamma. And the same holds for cosine. Cosine plus pi k is the same of cosine gamma for any k that is an integer. So in set, negative values are fine as well. Doesn't matter if you add or subtract by multiples. Let's have a quick look at the graphs of these functions. So here's the real line. Say 0. Then, all right, let's 1. This is about pi over 2 here. On the negative side, this is minus pi over 2. This here, pi. We'll map the negative side as well. So this here is minus. Now we can draw these function values. Let's start with a sign. Basically, the sign of 0 is 0. Yeah. Imagine this line here is way down there. Then nothing of that orange part is left. So the sign starts at 0 and then increases until it reaches 1 at this point. And then it decreases again until it reaches 0 at this point, and that is the rotation value of pi. Okay, so what it does is, again, on the positive side, it increases here until it reaches 1, decreases and decreases until it reaches 0 at pi again, and so on. And of course, same happens on the negative side. Now, if you rotate this down here, then this becomes negative until it gets to -1 here. So it decreases to -1 and then it increases again up to 0. So we get almost the same behavior on this side. Looks like this. Okay, so this is the sine function. And the cosine function looks almost the same. Difference is it starts at 1 and then it starts to decrease as this gamma rotates. Yeah, so here it reaches a value of 0. Then it goes into the negatives here. And so on. So that starts at 1. Reaches 0 here. Goes to -1 here. 0 here, and so on. So here, so this is 0 here, -1 here, and so on. So that's roughly the cosine function. Two more things I'd like to mention. The first is common shorthand notation for powers of the sine and the cosine. We'll encounter often. Might be used to that. It doesn't really matter if you're not. So shorthand for something like sine x to the power of n. Because we want to be quicker, we often write this as sine to the n of x. So that does not mean n times application of the sine, but it does mean apply the sine once and then take that value to the power of n. And of course, the same is true for the cosine. That same abbreviation exists. And one very important theorem that you have to know about sine and cosine is Pythagoras' theorem. You hopefully remember that one. So this is obviously a triangle, an orthogonal angle here, that corner. And that means Pythagoras' theorem applies here. This side of the triangle is always equal to 1, because that's on the unit circle. And that means square of this side plus square of this side sum up to 1. In other words, sine squared of x plus cosine squared of x is equal to 1. That's something that we'll often encounter. And you might remember from school there is a whole load of theorems about cosine and sine of double angles, triple angles, sums and differences of angles, and so on and so forth. We'll make use of that sometimes. I'll introduce these theorems when the time comes to. So it's not really necessary to memorize those now. But this one, the Pythagoras, you should memorize that, definitely. Okay, that concludes the introduction to trigonometric functions, and I'll see you in the upcoming videos.